Hello everyone, and welcome to this introduction module of the Procedural Asset Production Masterclass. In this video, I want to have a closer look at groups. And we'll have a look at what groups are in Houdini, how can we create them. We'll investigate different methods of manipulating groups, such as turn them into one another, transferring them, and combining them. And then we'll also have a closer look at how they work with attributes, like we discussed in the last video. So let's go over to Houdini, and I've created a little scene here that has some examples that I want to go over. So first, let's discuss what groups are. Well, groups in Houdini are basically a binary value that acts like a subselection on your geometry. And they are stored distinctively from attributes, though they do share some commonality. Okay, so let's have a look at these nodes here. These are the most common group nodes or group related nodes in Houdini that you will find, and you can find more of them if you press the tab key and look under the group section. Now, groups in Houdini have a particular role in that they affect how other nodes process their functions on geometry. Like I mentioned, they're basically a mask. So if I grab this sphere down here and I create a group node, which is the most basic node that creates groups, and I plug it in under the sphere, you will see that the entire sphere now lights up. And that means that this entire object is now added to a group. We can look in the properties or parameters of this group node and change some of its settings, such as the name of the group up here. So let's call this my group. Next to that, we can also specify different parameters, and we'll look closely at this in a moment. But for simplicity's sake, what I'm going to do is click on this button here on the right. And this allows me to select pieces of my geometry in the screen, such as a part of the sphere. Right now I'm selecting the primitives of the sphere. And then I can click accept. And now it has added this particular selection to my group. So you see that before the group was complete, like the entire object was selected because the pattern field here, the base group field, was empty. But the moment I add a selection, it selects specifically the primitive numbers, in this case, of this sphere. Now if I grab a node that would affect this, like a color node or a mountain node perhaps, then I can load in that group on these objects. So if I now grab this color node and I set it to primitive color, and I load in my group under the group tab of the color node, let's give it a different color so we can actually see what we're doing. You can now see that the grouped half of the sphere is turned red. If I grab a mountain node, and I'm going to plug it into the bottom of our group node here. And of course, by default, the mountain node is going to deform the entire sphere. But the moment we apply a group mask up here in the group field, let's grab it from the drop down, my group. Now you'll notice that the sphere no longer deforms, and that's because it can't actually find the group. The group type it's looking for are actually point groups, as you can see here in the description if I hover over the group field. And that's because the mountain node applies all its deformations to points and not to primitives. So if we want to fix that, we have to either take our primitive group that comes from this group node and convert it over to a point group, or we have to create a completely new group specifically for that. In this case, let's go ahead and create a new point group. I'm going to drop down a new group node here, plug it into our sphere and our mountain node, and let's give it a name. So the previous one was called my group. Let's call this one my point group. And let's change its group type to points. As you can see, now the entire sphere is selected. Let's go over here to the base group field, select the arrow, and let's grab a part of our sphere, then right click and click accept. Now, if I look under the info panel on this group node here, we'll see that we have a group called my point group, and it has 50 points. Okay, so with that, let's go to our mountain node, And we need to switch out our groups. So if I click on the drop down, we can now find my point group in the drop down instead. And the moment I select that, it will work. Now it's still looking for the old my group as well, but it won't find it. This is basically an additive system. We'll look into that in a minute. So I'm going to remove the old group to keep it clean. And now, if I go ahead and deform my sphere, you'll see that only the points that are in the group are being deformed. Likewise, if I grab a color node, drop it in behind, and go ahead and assign my point group as well, then by default it's going to be set to points, and we're going to see our point group reflected as point color. So this is what groups are useful for. They allow operators, such as these nodes here, to mask out their operations based on the groups that are assigned to them. And the types of groups, such as point groups or primitive groups, affect heavily on how these nodes apply their effects, or if they can at all. So next, let's have a quick look at how we can view the groups on our geometry. Specifically, how we can highlight them in our screen. Now, as I've already discussed, when we create a selection on our object, the group actually highlights in our viewport. But this is only visible as long as we have the group node specifically selected. The moment we do any other operations, like apply a color node to the end of it, we will no longer see our group. And this is because of the highlight flag. If I look up here under the list view, you'll see that this particular group node has its highlight flag enabled. And this allows me to see it as long as I'm highlighting the node. But this isn't the only way to know if there's a group on the geometry. We can also use the info button on the radial wheel on the node. And if there's a group present, you will find it here under the particular group section. In this case, we have a primitive group called my group, and it has 121 primitives in it. Other ways we can view our groups is through the groups and attribute list. If we click on this button, then instead of just highlighting our group, it will actually apply it as a color. Now the groups and attribute list allows us to filter groups. So in this case, I only have one group, that's fine. And then I can also specify which color I want in my screen to view it by clicking on the color button here. Next to this, we can also specify different types of groups. Now, right now, I'm looking at primitive groups, but I can also filter out point groups, for example, which I don't have on this geometry at this point. But if I switch my group node over to point group, then now you can see that the entire geometry is covered in red dots, except for the areas where my selection is not. Now this particular window here is very useful, and we will use it a lot. But let's continue on and quickly discuss the types of groups that are available for our geometry. Alright, so let's quickly have a look at the different types of groups that we can add to our geometry. We have one for every single type of element that we've discussed so far, such as primitives, points, and vertices. But we also have access to the edge group as well. Now when it comes to groups, edge groups actually hold a special status in Houdini. Unlike the other ones, edge groups actually don't have an attribute equivalent. Like there are primitive, point, and vertex attributes, but we can't actually find edge attributes in Houdini. And as such, when we create edge groups, some nodes have some trouble using them. But using VEX or specific nodes that are particularly catered towards creating or manipulating edge groups, we can work with them, and they can be useful depending on the situation. So next, let's have a quick look at how we can use the numbers of our primitives or points or other elements to make different kinds of selections. If I go over here to the right, I have another example prepared, and I just want to quickly show you the types of selections we can make. So here I have a group node that's creating a primitive group selection, and I'm creating a selection using the base group down here. And this allows me to select particular parts of my geometry. So I've already shown you that if I use the selection picker here and then select in my viewport and then right click, I can accept that selection. Alright, so that's good. It actually populates the entire list over here on the right. Now we can actually go ahead and click the picker again and then right click, and we can do a various different kinds of operations on this selection. But right now what I want to do is simply look at how we can make selections manually. So let's go ahead and empty this field. By default this will select everything. Now if I specify a single number like 0, it will only select that particular part of my geometry. Now we can expand this selection by simply typing more numbers into this field, like so, and that works too. Maybe we can add 6 and 7 to fill this one up. Alright. But we can also do this by simply going over here to our field and typing it in as a 0 dash and then the number we want it to go to. So in this case we're selecting everything between 0 and 5. And then I can continue from there and say I want 0.9 and maybe 0.11 to 15. And this will expand my selection to those sections. Of course, if you make a ranged selection like this, it has to be continuous. Now we can also use an accept feature. If we go over to this example, I'm using the asterisk symbol to select everything, and then the hat symbol, and then a selection, like I showed you before, to basically exclude a part of this selection on the sphere. We can then do this again by adding another hat symbol, and then we can simply type, say, we want to also set 9 to 15 as an exception. Alright, so that's basically the inverse of our previous selection, or at least close to it. And then the last type of writing that we can use here is by using the same situation, but with an existing group. So in this case, we're adding a selection and then we're subtracting from it. So this is a way to define your selections using the group context in Houdini. Now before I continue, I also want to have a quick look at vertex and edge selections as well. So here on the left I have vertex selections, and these are basically made using this type of pattern, where a single number will select all the vertices of the primitive that they belong to, and if you provide it as the primitive number and then the vertice numbers, you can select them this way as well. As for edge patterns, if we want to select edges, then we can do this by again selecting the active primitive, and then it will select all the edges of that primitive, or we can specify a range of point numbers, such as point number 2 to 4, so that will select this edge, or we can select a range, such as point numbers 3 to 7, and then to 56, and that will select this edge up here. And if we want to remove a selection, then of course we can use the hat symbol again, and in this case let's remove all the edges from primitive 81, and this will deselect this edge only from our selection. Now next, let's have a closer look at the different types of groups that we can make. And like I showed you before, we have different types of group nodes available, different types of nodes that affect groups. The first one I want to look at is the simple Group SOP. So if we look for it, you can find it under Group. And the Group SOP has a variety of features. Now we've already been looking at the base group selection method, but we also have other ones. Over here on the right, for example, we have the group by bounding region method. And the group by bounding region method, if we grab the handle tool, allows us to create a group based on a particular volume that we can define. In this case, we are defining it as a box, but we can also define it as a sphere. And then we can move that sphere around, and everything that touches that sphere, depending on this setting here, if it can be partial or complete, will be selected. So the next type of selection I want to look at is when we use the bounding object selection using points and vertices only. And this one uses the second input on the group node. So in this case, if I look at it, we can see that we have this blue outline of our test geometry here, this rubber toy. And it's actually selected a series of points on our sphere. Now to visualize this a little better, let me go ahead and activate this color node here. And if I move my rubber toy around by grabbing it, and let's say I change some of the position values on it, you can see that we're actually selecting different parts of our sphere depending on where they're inside of the bounding shape of this toy. Now the problem with this is that the geometry that we're providing does need to be solid. If it's not solid, then the group node might not properly know how to select it. Now the other thing about this particular method is that it only works on points and vertices. We cannot actually select primitive groups this way. In fact, it will simply give us an error if we do. Now the next type of selection, and the last one here, is the bounding volume. And when we're talking about volumes in Houdini, we're basically talking about either volumes or VDB volumes. Now in general, VDB volumes are faster than more standard volumes in Houdini, but they both work in a similar way. Basically, they're a form of 3D voxel space, a box that contains voxels, and these voxels can actually be used to select whatever's inside of them. So here I have the toy, and I've converted it into a VDB shape using the VDB from polygons node, which creates this volume space. And then we can feed this into the group node when it's set to bounding volume. And this will select everything that's currently inside of the volume. If I template the VDB node, you can see that we have this cuboid shape of our test geometry. And, well, everything inside of that shape is being selected. If I move my toy around, you'll notice that the selection moves with it. So that's all pretty straightforward. Now let's have a look at the next type of selection that we can make using the group node. Over here I have the normals selection, and the normal selection on the group node allows us to make a selection based on a particular orientation or direction. We can specify this by simply providing a normal over here in the field. So if I say I want a direction specifically towards the X orientation, then I can specify a direction of X as 1 and then Y and Z as 0, and then the range at which I want this to spread. This allows me to select everything that's facing in the X orientation. Over here in the bottom corner you can see the little widget. Well, that's the positive X direction of my screen. So that's what the selection is being made on. By changing these values around, of course, we can change the orientation accordingly. So now it's pointing towards the diagonal up direction here. And the last type of selection that we can find on the group node is the selection by edges. So if I go over here to this example, you can see that I've set the group node to selection by edges. And when we select by edges, we can only select on particular elements of the geometry. In this case, we can only apply it to primitives or to edges because they're the only types of geometry that actually contain edges. Right now I'm selecting based on a maximum angle. So I have this elongated like Zeppelin shape here, this oval shape. And if I expand my range for my maximum angle, you can see how it grabs more and more of the geometry. So this directly relates to the angle of this particular edge on the geometry. We can also set a minimum angle and select the opposite. This can be used in certain cases to grab parts of your geometry that have a particular angle. Next to this, we can also make a selection based on an edge length. Now I've set up a little example here of a couple of lines, of polylines. And if I look at them, we can see that each of these have a series of edges. Now, I have subdivided these, and I'll show you what that actually does. Over here on the left, I have a group node that selects based on an edge length. Now, as I increase this edge length, I'm actually going to select more and more of the edges. And you'll notice how it doesn't matter if the line is a solid single primitive with just multiple points in it, or if it is subdivided. And this basically just means that it makes the selection based on the edge, not on the primitive. So edges are actually in between points, right? This is an edge, whereas the entire object here is a primitive. This is the entire primitive. So there's the distinction to be made. That's what the edge selection is. Now the next example I want to make is when we are trying to use this feature here to expand a group based on a certain edge depth. And this basically expands a selection based on the edges in your geometry. So here you can see I have a particular point selected as point 13. If I grab other points in my geometry, I can likewise expand from there. And this expands the selection based on the edges of my geometry. Now there's a better way to do this using the expand node, but this is one way to expand your selection using the group node. Now last for the group SOP, we have this option here called unshared edges. And the unshared edges option allows us to select everything that's currently on the outside of a polygon. So if I go ahead and switch this to edge groups, you can see that everything that isn't included in this mesh somehow, that isn't connected to another primitive, this open edge, is being selected. We can switch this to the different types of groups, and everything that's adjacent to an open edge will be selected by this particular feature. This is very useful if we need to actually find the outside of a mesh and then group it. Then the next thing I want to show you is the group range node. And for this one, we can type group by range. And the group by range SOP allows us to make a selection based on a particular range. So here I have a grid, and this grid has primitive numbers on it. And this particular node can be set to select based on a range, in this case 0 to 39. So if I lower this and raise it, you can see how it progressively selects more and more elements on this primitive. And if I increase the starting point, we deselect everything below it. Next, we can also use this to go relative from the start and the end. So in this case, it actually subtracts a certain amount from the start and the end of this primitive. If the geometry has 80 primitives, like we can see here, or 81 in this case, then it will remove 15 primitives from the end. So this allows us to make a selection based on a range relative to the amount of elements actually present on the geometry. We'll be using this during the intro assignment. Several of these group by range nodes actually. The next one here is start and length. So this one's simple. We have a starting point and then we have an end point. So it progresses along the geometry, along the primitive numbers. And then the last one here allows us to say equal partitions. So in this case, I am dividing it into 4 sections, and we can divide it into each one a partition. Now the last type of feature that the group by range node has is the ability to select based on a range filter. Now in this case, that basically means that we can create patterns of selections. So if I change my maximum number, so in this case selecting one of 5 points, then it will proceed along the geometry and select every 5th point. If I increase the first value, I expand that selection so it selects the first 3 of every 5 points. So this allows us to make pattern selections, and we'll be using this during the intro assignment as well. Now the next type of node I want to show you is the group by expression node. And this node is actually really versatile because it uses VEX. Now we won't be diving into VEX too much right now, But if we create a group by expression node, this one, then we can actually field it with a VEX expression to drive what we're currently selecting. And this is pretty powerful, because VEX itself is pretty powerful by nature. I'll go more into what VEX actually is in Houdini later on, but right now let's have a quick look at what this node can do. If we look over here in the node itself, we can see that we can have a drop down here on the right, and this allows us to select a particular script that's pre-written and comes with the node. We can also write our own scripts or manipulate it. So right now what I've taken here is the 30% chance expression, and this will select a random selection at 30% on our geometry. Now if I go back and undo my change, then I've actually added in a parameter down here to the expression that allows me to change the random seed that this particular selection is using. Then I can also go here and change the value for the random chance, say set it to 0.8, and now I can have a larger selection of objects all at 80%. So in this case, this is a very useful way to get a random selection of groups in your geometry. We can do the same thing, of course, for our point selection. Now, the group by expression node comes with a lot of different examples. Over here we have a selection based from the center of our grid. This one here selects everything that's on one side of our x-coordinate. In this case, if we look here on the right, you can see the location on the x-coordinate that we're using. So we can set this to -2, and now it will select further to the right. Let me show the origin so I can demonstrate that a bit more. Alright, so this is the positive x direction. So if we move this into negative, it will select everything below that. So next up here we have a way to grab every first vertice of a primitive. So here you can see the vertice selection is being made, and this is for every primitive. This one here selects every piece of geometry that has a triangle in it. So every primitive with 3 vertices is being selected. And then on the other hand, we can also say grab this piece of geometry, which has a couple of its edges removed using a dissolve node, and then the group node allows us to make selections based on that. So every primitive, in this case, that has more than 4 vertices is being selected. So we can select these odd shapes inside of our grid. Now if we're talking about VEX expressions, we can go even deeper, and this really goes into VEX, so I won't go too deep into this right now. But if I look over here, we can see that we can use a attribute wrangle to create a group as well. And for this, I don't actually have a highlight flag, so let's go ahead and use the group and attributes display. Then I'm going to switch this to primitive mode and make sure there's an asterisk in there so I can see every group currently on my geometry. And right now, I am basically selecting my group selection on the attribute wrangle, like I could normally do with my pattern definition. And then every single group called group 1 is being set to a value of 1. Or in other words, the group is turned on these primitives. So if I look under the info tab, we can see that we have 27 primitives here grouped under group 1. Now likewise, we can use this same system to then make a separate selection and then set the groups back to 0, and this will disable those groups. So here we turn all of them on, and here we turn a particular selection off. Likewise, I can give this a different name and turn this on. And now I will add a second group to my geometry as group 2. This is a way to do it in VEX. Next, we can also use some more complex expressions, like here for example, I'm creating 2 groups. The first one's group 1, and that's being applied to everything. I'm not actually using the group field right now. Instead, I'm using the primitive number in VEX and a modulo expression, meaning that it will select every second primitive, and if that is considered 0, modulo basically just keeps counting until it reaches the certain number and then starts back at 0. So in this case, every second point is selected. It's very similar to the group by range node in this case, and that gets grouped as group 2. And over here on the right, we can combine that with our group selection up top. So now we can basically create this same pattern with just one node. So it's like combining the group node and the group by range node, and we can create multiple groups at the same time this way. So VEX allows us to do a lot of flexible stuff really quickly using just a few lines of code. But like I said, I won't dive too far into VEX right now, so let's move on to the next set of nodes. So the next node we're going to look at is the group expand node. And the group expand node allows us to do a very similar thing to what the edge depth feature did, but it's a bit more versatile. So if I have a group here, as you can see, I have group 1 on my geometry. Now the group expand node allows me to expand it based on a certain amount of steps. It even allows me to reduce my groups, basically shrink my groups. Now the node does have other features as well. If I look down here, we have more options. It allows us to bind this particular node to attributes. I'm not going to go into this right now, but one of the features I do want to show you is how we can use this button up here to turn on and off if it should share edges. So in this case, if I turn it on, it only expands the groups based on the edges that it shares. If we turn it off, it does it based on point connections. Plus we can also tell it to flood fill the entire connected geometry. So in this case, if I were to grab some pieces of this geometry and delete them, like this corner here, and I plug this in front of this group expand node, and I turn on flood fill, then it will fill every single thing inside of this connected geometry, but leave this part alone. So this is another way we can use the group expand node. It's pretty useful in some cases. So next, just like with the attributes, we can also promote our groups. Over here I have a group promote node. So I start off with a primitive group, again primitive group 1, and then this group promote node simply turns it into another type of group. So in this case I'm promoting group 1 from a primitive group to a point group, and we can change some of the settings around, such as if it should be included in the boundary, if we want to keep the original group or not. So in this case we actually keep the primitive group, but we still have the point groups now as well. And if I move further along, we can see we can also change it to different types, such as edge groups in this case. And if we use the other options down here, such as include only elements entirely contained in the original group, we can basically group whatever the primitives contained without spreading any further. So the group promote node is a very useful node. We'll be using it a lot because it actually has functionality that isn't very easy to replicate unless you're using VEX. So let's move on from here and let's have a look at the group rename. Now this one's very similar to, say, the attribute rename, and the main reason for us to have it is to simply remove an old group and rename it to another one. So in this case I've renamed group 1 to group 2. And oftentimes when you have a group node, it will also tell you underneath what it's doing, just like some of the attribute create nodes. It's actually quite useful if you want to know what it's creating, like what type of attributes or groups it's processing. And then finally here, before moving on to the more complex ones, we have the group copy. And the group copy allows us to copy groups from one piece of geometry to the next in a very straightforward manner. If we have one piece of geometry like this one, which has a certain amount of primitive numbers, and then we have another piece of geometry which has another set of primitive numbers, and that one has a group, then we can copy all the groups from this one onto that one based on the primitive numbers. So we'll just try to copy them one to one. In this case, that means that because this grid only has 25 squares, it will only copy the grid groups from primitive 0 to 24, right? 25 primitives. Then next we have the group transfer node, and the group transfer node allows us to transfer groups based on world space coordinates, a distance in 3D space. And it will transfer it from one piece of geometry to another. So in this case I have a grid and I have a sphere. So let me plug one of these spheres in, and what I'm transferring at this point is point groups. So let me switch this into point display so we can see this a bit better. And if I grab my sphere and I move it around, we can see that we're moving the groups along with us. So this is a useful way to select pieces of our geometry using another object as an input. And this of course uses the second input here. When we have a node with two inputs, the first input is always the one that processes the main geometry, and the second one is often a modifier. This differs per node, but that is in general the rule. Now if I plug in a bigger sphere here, you'll actually see that our selection gets a bit more hollow. And that's because our sphere is hollow. Unlike the volume selection that we could do before, this one isn't, and whenever our points get too far away from the points on this sphere, our selection is undone. So if I lower the amount of frequency on the sphere, you'll actually see that it only selects points near the points on the sphere. It doesn't select it based on the geometry of the sphere. For that we have to use different methods. And then over here on the right, let's have a little bit of a closer look at how groups are transported using the group transfer node. So here I have a sphere with a high density. And over on the right I have a sphere with a low density. So this one has a group on it, again group 1. And if I transfer this group from one to the other, and I highlight that, again I need to show my primitive groups, then you can see that it did transfer it, but if I try to transfer it in a larger range or a smaller range, well, first it transfers it only from the centers of these primitives. So that would be the center of these primitives. That's where it transfers from. And you can see how it doesn't actually transfer at the corners of this sphere. Let me slightly enlarge this thing so we can see the wireframe a little bit better. There. Okay. So now, if I increase this range, you'll see that it actually stops transferring. And it does this because our source geometry actually has on and off values for our groups. If I look in the geometry spreadsheet, we can actually see our groups in here as a group attribute representation. So I mentioned how groups are booleans. Well, if we scroll down this list, we will actually find our on-state groups right here. But all the other ones are marked as off. And the group transfer simply copies that state from one object to the other. If we're copying from this object to this one, then what we're actually doing is copying the on and off states. So if we want to only copy the on states, we have to actually get rid here of all the off state geometry. So here I've used a blast node, which is a very efficient deletion node, which is removing all of the geometry that's not in our group. We're doing that using the delete non-selected state here. We can actually do this as well using the group field. If we go in here and we type an exclamation mark in front of our group name, we effectively do the same thing. This is just an easy way using the node. And then because we've removed all of the off-state geometry, all the non-grouped geometry, when we transfer, there's nothing to prevent us from transferring any further, so we can simply expand our group as far as we want to, like so. Now there's another node I want to quickly look at, and that is the group delete node. Now let's say we're creating groups, and that's fine, but here we have an example where we are coloring a piece of this sphere and we have a group on it. Now once we don't need the group anymore, if we don't go ahead and delete it, it's going to stay on our geometry and it's going to populate all the other geometry we're processing. Well, the group delete node allows us to simply get rid of the group. So now, if I look at the info panel, here we can see we have group 1, and on the group delete node, it's removed it. Now we can specify different sets of geometry. So if we want to delete point groups and primitive groups, we can do that right here. And we can also use it to delete unused groups. So in case we have removed all the groups or all the primitives in our geometry that have a particular group, like let's say with our blast node over here, let's copy that, plug that in, and let's invert our selection. So instead it actually deletes all of our groups. Then now, if we look under the primitive groups, we see there are no group 1 groups anywhere on this geometry. Then we can either use the blast nodes feature, delete unused groups, to get rid of the groups this way, or we can use the delete group node later on perhaps to also do it this way. Now there is actually a reason to have empty groups in your geometry, and this happens when you're trying to process groups with one another, when you're trying to do some group math. And we'll talk about this in a minute when we discuss group errors. But before we can do that, we should first discuss how we can merge groups and how we can combine them together. So speaking about merging groups, let's have a quick look at this example here. So in this case, we have a grid which has a group called my first group. This is a primitive group, and it selects this part of the geometry on this side. Then I have another group below, in this case in a group expression node, that's selecting the top half of this geometry. Now in this case, both groups have different names, so they coexist next to one another. However, if we grab this node, then we'll see that we're actually replacing the my first group. And that's because the merge operation type here is set to replace. Now there's other methods as well, but basically every single group node that deals with creating groups has some form of this drop-down menu. So if we grab a group node, we will find it here under the initial merge option as well. Now the other options available besides replacing the group entirely would be to union them, so basically merging the two groups together, adding them together. We can also do an intersect, which grabs only the overlapping sections of the two groups. And lastly, we can also do a subtract, and that just takes the first group, which was located here in this section, and then subtracts the second group from it, which was located up here. So we only have this left. Now, in case we want to do some more advanced group math or advanced group combination, we can use the group combine node. Now in this case I have the same example as before. I have my two groups, my first and second group, and then I added a group combine node behind it, which creates a new group called my combined group. Now I'm doing this over here in this menu, where I have my combined group specified as the group name, and then I say everything that equals my first group, so this zone here, and intersects with everything but my second group. So in this case I've basically inverted my selection. And of course I can say with, and then it will select this half. So in this case I'm basically just saying everything that's not in my group here, that's part of this. So this is effectively a subtraction, right? I could do this too with subtraction mode and then say with. So this allows us to combine groups together and create them into new groups or override existing groups. If I grab my first group and I add it to the beginning, then now basically I'm replacing the original my first group this way. So the group combine node is pretty powerful if you need to combine groups, but it does have some issues. If we look at our group error section here, and I look at the left example, you see that it actually errors out. And this is caused directly because we don't have our initial group. We are asking for my first group here, and it's missing. So in this case, my first group is not a valid group. So if you're ever using a group combine node and you're generating geometry and you're missing that group, then the group combine nodes will always crash on you. Like, they will error out or they will cause bad results. So a way to circumvent that is by creating a dummy group first, basically. And a dummy group can just be an empty group holder. We can do this through several different methods. The first one here is using a group create node. Now right now this one's set to replace. Now we don't want that because let's say we, under normal circumstances, do have a group, we don't want to actually get rid of it. So in this case we can use the union with existing option and then just say everything but. So in this case, this group node will take the existing group it's looking for and then union its own selection with that. But because we're not selecting anything, we're creating an empty group. So here you can see under the info panel, this node has created my first group, but it's empty. It's a dummy group, right? Then we can do this in a slightly easier way, and that's using a wrangle node. And that's by simply defining a group name over here. And when we access a group name in a wrangle node, it will always create it, even if there's no information being set. So if we want to set a value to this group, we have to type equals 1 or 0, like this. But if we specify it without the equal symbol, then we simply just create the group, but it has 0 data in it. So again, we have the ability to create a dummy group this way. Now, if we look at the combined nodes, we do have a group. We just don't have anything to really work with, but at least the nodes aren't erroring out. So if you're going to use group combinations, if you're going to use group math, make sure your groups are always present on your geometry, because otherwise, in my opinion, it's easier to use attributes. Now to finish up this lecture, let's have a quick look at how attributes and groups work together, because we can actually turn them into one another fairly easily. So let's start with this by looking here on the left at this example, where we again have a high resolution sphere and a low resolution sphere with a group. And we're using this group transfer to send a primitive group over onto the high res sphere. All right, that's something I've already shown you. But here we have a point caller node, which is taking the primitive group and applying it to its points. So in this case, it does what the other groups did before. It just takes whatever primitive you select and selects all the points around it. So this is an automatic group promote, and we're using a group to set an attribute, right? This is an attribute as the caller attribute. Now if we look at this example on this side, we're using the group node with its bounding volume to select a series of point groups. And then we have a group promote, which turns it into a primitive selection. And then we can say color that selection with this color node. Now here on the right, I have an attribute create node set up, which actually takes my group and, just like the color node, applies attributes to it. In this case, my own attribute. Let me display the attribute in my viewport using the display options here. And as you can see, wherever my group resides, it actually has turned the attribute, my attribute, to 1. Now if I want to delete my group, I still have my attributes on my geometry. They're still set to 1, but now my group is gone. Now I can still recreate my group fairly easily. For example, I can use a group expression node and simply say, if my attribute is 1, then create a group. So this allows me to recreate my groups using my attributes. And in fact, then I could again say, use an attribute delete to delete the original primitive attribute. Now, there's one last way to promote your groups to attributes, and that's quite a simple one. Over here we have our group promote, which is taking our point groups and turning them into primitive groups. But instead of having to create an attribute create after it, we can also use the group promote node itself to output an integer attribute as well. In this case, if I click this button, instead of outputting a group, the group promote node will actually generate an integer attribute with the same name as the group. So in this case, it's created group 1 as our group. After this, of course, if we want to give it a different name, we can either say add a new name here. So this could be my attribute. And now it has created my attribute instead of my group. Or we can plug in a rename node after it, such as the attribute rename. And then we can rename the primitive group to whatever. So in this case, it could be group 1 becomes my attribute. And then of course, we need to make sure we're outputting group 1. So here the group promote has turned the group into an attribute called group 1. And then this attribute rename has turned it into my attribute. So that's all fairly simple, right? We can use attribute promotes and group promotes. We can delete groups, we can delete attributes. And there's often reasons why you want your attributes or your groups to carry each other. Because some nodes have trouble processing groups properly. Some nodes don't keep your attributes intact. And we'll cover this during the class to some extent, and especially into the later modules when we'll start to deal with more advanced curve manipulation. And then the last example I have here is simply how we can use attributes to create groups, say in this case with a color. So let me hide this template. Here I have a sphere, which is using a color node, and this color node is set to bounding box. And this creates a color based on the XYZ coordinates of this object. And, well, it's bounding box, basically. So here on the left, I have a group by expression node, which is set to group everything that has a red value that is higher than 0.5. Okay, so in this case, it's selecting everything on the red side of the sphere. Now we can use an attribute wrangle node to create a little VEX script. And in this case, all I'm doing is just adding it together. Again, I'm not going to go into VEX right now. But what this does is it allows me to tune my selection. And again, because this is a wrangle node, I have to view my groups like this. Okay, so here it is. If I go and change my values, if I set everything to 0, it will select everything. But if I select, say, the blue threshold, then it will select everything only on the blue side of this sphere. And I can do the same thing for the green side, and maybe for the red side, until I'm happy with, you know, my selection. So these are some various different ways that we can select groups, and I'm not going to go any further than this. I think we've covered a lot in this video. And in the next video, we'll have a closer look at how we can actually work with parameters in our interface, how we can work with references and parameters. Alright, so that's it for this video. I hope you found it informative, and let's move on to the next one. Have a good one.